Another example in which we can find the solution of ODE is if we can write the ODE in this term. There's obviously a lot of x and y terms that's added, subtracted. So it's not actually a good idea to try to separate the variables. The first precision separation of variables is not kind of that smart. The second idea, if we can write everything in terms of y divided by x. So let's try if we can write everything in terms of y divided by x, which I think we can. So let's divide by the highest power of x. What is the highest power of x? Is x the third. So divide everything by 1 over x to the third, 1 over x to the third. In the left hand side, we end up with y prime plus y divided by x all to the third power minus y divided by x to the first power, which is equal to 0. So we actually rewrote everything in terms of y divided by x. The second step, as I said in the YouTube videos, you put y z equal to y divided by x, or y, therefore y is equal to zx. Because you want to get rid of y prime and put everything in terms of either z or x to differentiate this thing. You end up with y prime is equal to the derivative of the first, second, plus. So you will end up with z prime times x plus z, which you can put it back into the equation and substitute the value of y over x, which is equal to z. So do those things together. So z prime times x plus z plus z cubed minus z, which is equal to 0. Z and z will cancel each other. You will left out by z prime times x plus z cubed is equal to 0. So for that, from here you can do separation of variables. So dz divided by dx. So this is the third step, as I said in the YouTube video. So first, in substitute, try to write everything in terms of y divided by x. Second step, put z is equal to y over x. Change the differentiation thing. Now everything will be a separable differential equation. This dz divided by dx times z plus z cubed is equal to 0. We can put z cubed in one side. So dz divided by dx times x is equal to negative z cubed. Therefore, dz divided by negative z cubed, which will equal to dx divided by x. And you integrate it. That one will end up by 2 divided by z squared will equal to ln absolute value of x plus c. Don't forget the concept of integration. Last thing, we want to solve stuff in terms of the first thing, we want to solve it in terms of z squared. So this thing will be equal to 2 divided by ln absolute value of x plus c. So z is equal to the square root of 2 divided by ln the value of x plus c. Now we have to rewrite everything in the term of original variables. So now z is equal to y divided by x. As I said in the beginning, that's what we put y z equal to. So we can write y is equal to x times 2 divided by ln for absolute value of x plus c, and that's the end of this problem.